Agenda for the first part, what we are going to start with, what is big data in general, how the history of Hadoop and how all this started. We'll talk about data use cases, and finally we'll sum it up with what is Hadoop in a day-to-day life. And here we want to present like a story and talk about the basic concepts of the foundational around big data and Hadoop, and why is big data such a popular topic, why is it has all the secret sauce which makes it successful. So that will be the highlight for this part of the session. So what is big data? Before we go to big data, let's talk about teeny data, or how this whole revolution around big data started. So I would like to start way back in the caveman days when human beings were staying in caves, and that time itself they had this fascination to collect data. And this cave paintings which human beings started is the entry point of collection of data. Obviously, this is not big data. This is not even big, small data. It may be a tiny data because it's hard to write amount of collection of information from these drawings on the cave walls. As we progressed as civilizations, further inventions like papers came into being. People started writing lots of manuscripts and written material, and that increased the amount of data being collected, and it continued to grow in the electronic age when we really had typewriters and electronic PCs, personal computing, which is the phase which we have passed. At this point of time in my mind, we are into this phase. We are into a phase of mobile revolution, as well as we are seeing a whole churn around the social media. We have several devices. PC is no more our primary device. Our choices of devices may be iPads and iPhones and several other phone devices, or we keep on uploading a lot of information around social media, whether it is Facebook, Twitter, and several other social media sites. So that's where we are sitting right now, but that's not it. What we are going to see a whole new revolution, which also is our focus about IoT, which is Internet of Things, where so far what has been seen is human being collecting the data. We have been entering data in some form or shape. What's happening right now, and started to happen more and more, where machines start to collect the data, or they are going to be collecting data, whether it's form of a weather sensor, whether it is form of a face detection mechanism which we have through our security cameras, all that kind of information which is going to be collected through machines. And that's a big revolution. The brink of a big change in our whole technological space, and we have started to see some of it already. And we already hear about Google's driverless cars, and all this revolution around not going to happen without having big data supporting it. And artificial intelligence and all the changes which are happening needs big data. So that's the correlation between big data and a lot of this technological advancement. I would see more of this artificial intelligence, Internet of Things as a bigger umbrella, and that cannot be supported without having big data as a fundamental element within it. So that's the correlation. That's how the journey has started about how big data, and we are only going to continue to keep on increasing the amount of data collection from here on. Way of looking at big data. This other common way which we hear in the industry is this 5 V's around big data, or 3 V's around big data. So let's quickly briefly talk about that as well. First V is the variety of data which we collect. Previously, when we started collection of data, it was mostly in databases, in a structured data format. What now we are seeing people collecting data and processing that data in various forms and shapes coming in, whether it is images, it is videos, it was network sensors. All this variety of data is not only being collected, but we have capability to really process and do intelligent things on top of it. So that's the variety part which we are referring. Then comes the velocity. We live in a world of instant gratification. Not only we want useful information and huge amount of data processed for us, but we want it instantaneously. We want it now. A very good example of this happening is, assume you have a mobile phone and you got an email from your friend sending a message like he's coming from an airport from certain place. And at certain point of time, when it's all time to go and pick him up on the airport, what Google would do is he'll pop up a message saying, oh, you need to leave at a certain point of time to be able to reach to the airport. That's the power of velocity. What really is happening behind the scene is several things are happening. Google, first of all, has parsed the emails and it has collected information that is something related to airlines. It has connected to the airline's particular air flight data and looked in the timing of it, looked at your particular location and the distance to the airport, and looked at the traffic across, and instantaneously given you this information after so much of processing. And we take it for granted, but that's the power of velocity, which is happening right now, and we should be gratified to have such kind of a great processing ability. Is the volume, which we briefly talked about in the previous slide. The amount of data is only going to be more and more what we collect. But the main point which I want to highlight here is you looking at those two colors of part of the graph. One is the blue color, the relational data, which is the databases and the structured data. As you notice, that is saturated. The growth on that space is limited. What really growth is happening is in the complex and unstructured data. That's the data which can only be tamed and handled with big data technology. These were the initial 3 V's. The fourth V was added later, which is called veracity. Veracity primarily means the data quality. The data which we have got, not only it has to be a variety of data, a huge amount, and it has instant processing capabilities, but it has to be correct. It has to be the right data. That's where veracity comes into it. All the master data management, data quality concepts were brought into big data, and that's been implemented across these days. So that's the fourth V. Finally is the value. Value is part of any implementation, and this overall spectrum of different V's should provide us valuable, rich information, which lots of great companies, billion-dollar companies have sprung up these days, whether it is Uber, whether it is Airbnb, and several other companies which are primarily data companies, and they become enormously successful. So those are the 5 V's. That's the second way of defining big data. We may have all of these in your implementation, or you may not have all of these in your implementation. A lot of people talk about, I don't have a volume problem or big data problem, which is okay, but you may have a variety problem. You may have to handle with unstructured amount of data or semi-structured amount of data. So you may have one or many of these things happening into your environment, and that could result in for you to need big data. Back and talk about how this whole thing big data and Hadoop started. So this is a quick timeline, which is about starting back in 2002. But there's a lot of people which think like big data just started a few years back. So why is this thought process or notion whether it is just started a few years back? Actually, just for Hadoop, for this year itself, we are celebrating like the 10th year anniversary for Hadoop, when it started back in 2006. So there is a reason why we feel that this whole big data revolution has started a few years back. I'll touch that in a few minutes, but I just want to step back how this whole thing started. This whole thing started with companies like Google and Yahoo, primarily Google. Back in the 90s, when it started with an ambitious plan to really crawl the whole web and create a search engine for crawling the whole web, at that point of time, that's which is called the huge volumes of data. Google had brilliant minds, and with those, it really solved those problems. Solved the problems and came up with these interesting solutions, but it shared those solutions with the world. And it shared it through this white paper, which is called as GFS, which is Google's file system, and the MapReduce papers. So these papers were enlightenment for the rest of the world to see how this huge amount of data, which can be really processed and used, which a lot of companies have been holding it or archiving it or just throwing it away. So that's changed dramatically with the event of this white paper. I took note of it, especially the person called Doug Cutting. If you may have heard about him, he's also called as the father of Hadoop. He really was working along with Mike Cafarella on this initiative called Nudge, and he transformed that and really took a lot of changes around from Google and created DFS, which stands for Distributed File System, and MapReduce, which was added to Nudge. MapReduce is the processing engine. So this is how it started, first of all. then what we saw is it got transformed into a name called Hadoop. And in this moment, I just quickly want to just bring in some fun tidbits, and people may know how this yellow elephant came into the being for as an icon and why Hadoop got its name. So Doug Cutting was thinking about a name for this project, and his son used to be playing with this yellow stuffed toy and animal, and his son liked it and called it Hadoop, and Doug took that name, and that has been the name for Hadoop from the very beginning. So that's a quick side note if you were not aware of that. Another interesting fact I want to bring into this particular slide is if you notice these different names on the slide, there is something interesting and common across these names. I just want to give you a few seconds to think about what's common between these names. So there are double O's in all of these names. So there is a myth in Silicon Valley that if you name your company with double O's, it could be very successful. And why not? I think Google is very successful, and Facebook and Hadoop and Yahoo had its golden days as well. So there is some truth to this myth maybe. But there has been several companies which have tried that and not been successful. So it's just a myth for that matter. So that was a side bit. I just wanted to throw it out. In this timeline over a period of time, more and more things have been happening in the big data space. So coming back to my original question, why do we feel that it has happened in the last few years only and not such a long time back? There is a reason for that. In 2008, all this big data and Hadoop work was primarily play of these Web 2.0 companies like Google, Facebook, Yahoos of the world. Enterprises of the world like the Ciscos, the GEs, and the Visas of the world, the corporations were not interested in the open source revolution. They had a resistance for that, and primarily mainly because of the supportability of the open source world. They were not against Hadoop as a technology, but primarily they were more concerned about the supportability of this whole system, which can be provided through this open source world. At that point of time, there is a company called Cloudera which was formed, and they looked at this as an opportunity, and they said the world is interested in this software. They want Hadoop to be used for their big data problems, provide support, and that gave the birth of Cloudera. That was the point when the rest of the world, the enterprises of the world, started using big data, and that's the point I think we have started hearing more and more of that, and that's the feeling by that we have that Cloudera is very important, and how big data has come very recently to mind. So that's an important milestone in my mind. So Google starting with the white paper is the first seed of the big data revolution, and the second aspect which is happening formation of how this thing. So people are putting on the chat some questions. Yes, we'll be talking about GFS and HDFS in a few minutes later as well. Data forms and joins together as Cloudera. He's part of Cloudera. He's a chief architect at Cloudera at this point of time. There are more and more exciting things which are happening around the big data timeline and this growth. It's only showing up to 2009, but only more and more things are happening right now in the big data space. So just wanted to bring you guys with some information around and some fun, interesting pieces of information around this timeline. How is big data being used in the industry? It's not being just used in one particular sector or domain. This particular pictorial view, it's a great representation which just tells us how it's being used across different domains, whether it is finance, marketing, pharma, all of these, and also highlighting several different applications and use cases which happens. Primarily, customer is a big part of any implementation, so customer analytics happens to be a big part of it, and this provides a good pictorial view where how it is being used in several different use cases, whether it is risk analysis, it's fraud analytics, threat analysis, and so on and so forth. And lots of companies have thrived and became billion-dollar companies, whether it is Facebook's the world or Twitter's. All of these in my mind are data companies. They primarily are enablers to provide data for us. So about Hadoop, what is Hadoop and what does it do? So here is where I want to switch gears, and instead of talking about just as bullet points and concepts, here is what we're going to switch. Let's talk about how Hadoop provides this goal of being scalable, economical, and reliable through a story. Share a story which would help us really understand the foundational concepts of things. So far, it was more of a background, and let's try to understand. This is the core of this session, hopefully. We'll provide some foundational aspects about Hadoop, how those elements which we just talked about can be provided with through us to remember that and retain it for a longer point of time. So here goes the story. So this story is about a passionate teacher. She has a small classroom of, let's say, 6 students. She teaches them a topic every week, and the end of the week on Friday, she gives them an exam. The exam, she takes the answer paper and goes home on the weekend, corrects the answer papers, gives them grades, A+, B-, whatever the scores which may be. Life is all good. She spends around maybe 15, 20 minutes, 30 minutes in the weekend to check those papers. Everything is all good. What happens, the popularity of her class starts increasing, and more students start signing up for the course. There are people signing online. So instead of having 6 students, she starts getting 50, 100, and so on and so forth. Now what happens on the weekends when she takes the paper home, the amount of time that those paper corrections take is increasing. It's increasing from 100 minutes to 2 hours, and several, sometimes even the whole day she's spending on this activity. About that, very passionate about teaching. So she comes up testing solution, and many of you may have already seen this solution or some kind of variation of this happening in your own school time or in your kids' school time. What the teacher does Friday when she gives the exams and the kids write the exam paper, she does not collect the paper. What she says, keep the answer papers with you. I'm going to put the answers on the whiteboard. You can self-correct it using a red pen or give it to your neighbor to get corrected, and so on and so forth. So this mechanism, how she solved the problem, now whether it is 50 students or 100 students or even 1,000 students, the correction of the papers only takes 15 minutes. And unknowingly what she has done are very much similar principles of Hadoop. And I just want to break this part into bite-sized pieces to explain like why I say that this concept, what the teacher has done, is using a lot of concepts from Hadoop. 4 principles of Hadoop. So what we'll do, we'll quickly talk about the classroom example and in the real world Hadoop example to understand the secret sauce of Hadoop and big data. How does it really address the scale problem which the teacher had and the rest of the world is having? Let's try to break the classroom situation into 2 parts. One, scenario 1, where the teacher is correcting the papers, and scenario 2, where the kids are self-correcting the papers. So in what's happening in scenario 1, the teacher is correcting the papers and she's serially correcting one after the other. But in scenario 2, what happens when she writes the answers on the whiteboard, all the kids are correcting it simultaneously, and that's what is called as parallel execution. Parallel execution is almost the secret sauce which Hadoop and big data technologies are using. So let me dive into the big data world right now and understand. In a big data world, everything is represented like a cluster. What is a cluster? A cluster means a collection of different machines where one of the machine is considered to be a master machine. Let's consider this teacher as a master machine, master node. And there are many small nodes which can be called as the slave nodes. They are commodity software, hardware, simple machines, which can be hundreds or thousands of those. And these are the ones which will be performing the work in parallel. So if you have a big problem to be solved, all of them work together simultaneously on their part of the problem to get the end result. And that's how a cluster in Hadoop is able to solve the and use parallel execution to address the scale problem. So that's the first principle behind big data's success. Data locality. So what is data locality? Let's talk about the teacher. In the first scenario, checking the papers every day from all these kids and every Friday and taking it home. Act of her collecting the papers was not producing any value. It was a waste of time for that matter. none papers were getting corrected while she was doing this collection. Problem what happens in any data environment, when you move data from point A to B, that is a bottleneck. The I/O becomes a bottleneck and a challenge. What Hadoop and many of these big data technologies have solved these problems and put it on its head. What data is going to be stored at different nodes, and the data, let's say there is a terabyte of data on all of these nodes, so we are having 6 terabytes of data. Instead of moving the data from one place to another, what we are going to do, we are going to send the program script, whichever is needed. Let's take a quick example for that. Let's say I want to find who is the richest person in the United States. And my data is, for simplicity, is structured in such a way that each of these nodes, let's say there are 50 nodes, so on and so forth, and each of the node is storing data about one state. One node is storing the data about California, one other one is on the Texas, and so on and so forth. That would not necessarily be the way the data is stored in a cluster, but just for simplicity, let's go with that example. And my problem is to answer who is the richest person in the United States. To get that answer, when I give it to a cluster like this, each of these nodes will start processing the data of their part of the data. So the California node will find me the richest person in California, Texas node will find me the richest person in California, and Texas, and so forth. And what is happening, all of them are working together to give me the results and the output and allowing me to have this parallel execution. But at the same time, there is no movement of data from one part to another, which allows us to really not have data movement. I can send a program to all of these nodes, which always is going to be a small size of file, a program or script, which even if it's thousands of lines of code, it will be few KBs of file versus moving a terabytes of data. So that's what Hadoop and these principles do, where you can really move the data of the program into these nodes. And that's what is data locality. By definition, what data locality means, process the data where it resides. So instead of moving data from point A to B, let the data be right there and process it right at its location. Parallel execution and data locality are the two core concepts and the secret sauce around big data. The rest are to really more maintain and make sure that things continue to happen. What is fault tolerance? Really means the system should continue to work even in event of hardware failure or any kind of network failure and so on and so forth. In the example, let's think about the teacher if she is on vacation or sick for that matter. In the scenario 1, none of the papers will get corrected. The whole system comes to a stall. So 2, she could send some substitute teacher to just write the answers on the board, and that would be relatively very easy to do. Or a kid could put the answers on the board, or some monitor could put on those answers. So there is a somewhat of a fault tolerance built in the classroom. Same way in the Hadoop environment, what happens, let's carry forward the example which I was saying. What Hadoop does by principle, there is a concept called replication. What replication means, making a backup copy of the data. We do this in our day-to-day life as well. Let's say you have a passport or some important document, we take a backup or copies of those documents, right? Same way is the principle which Hadoop does. It thinks everything is important. So whenever a file has been given to Hadoop, it by default makes 2 more copies of it and creates always 3 copies. 2 of them are redundant copies, ensuring what we call as capability to really have the data available in case one of the nodes goes down or multiple of the nodes go down. Still, the system as together should continue to function. Let's say we had this particular node, which is this girl having California data, and that node went down. But in Hadoop, by principle of replication, would have the data in 2 other nodes. And that's how the processing can continue. I could find the richest person in California still. So that's how the system as a whole is fault tolerant, but individual components may not be fault tolerant. A single machine can go down at any point of time, but a system as a whole is fault tolerant. So that's what fault tolerance capability in Hadoop is brought by building a whole mechanism of a cluster rather than having a big single giant machine, which can fail and the whole system comes to a stop. The last principle, scalable, actually that's very straightforward. In the classroom, the teacher is no more concerned about having the scale. She actually is excited to be able to teach lots of kids in community. And what she can do, all this concept paper still gets corrected in 15 minutes, whether it is 100 kids or 500 kids. Similarly, in a Hadoop environment, what happens in case you wanted to really have this data, more and more data processed, you add more nodes, the slave nodes which we are talking about. You keep on increasing the amount of slave nodes, and that's why you call it horizontal scalability. You keep on scaling those and achieve scalability into a system. So those in a nutshell were the key founding principles around Hadoop and big data, which were happening in the classroom. And I hope through this story, you can understand and remember for going forward how these core principles are being used and done. Pause for any question answers. I'm going to pause the recording.